Hello children, how are you all? Welcome to Eduvibe, the vibe of smart education. So children, now we are starting the grade 8 textbook of science and the name of your book is Curiosity. Children, the first chapter of your book will be exploring the investigative world of science. So in this chapter, we are going to explore the investigative world of science that is full of facts and obviously surprises. Let's start with reading. Our journey with curiosity into the world of science continues in grade 8. So children, you must have read about the world of science in class 6th and 7th as well. Now we will continue in grade 8 also. We hope you bring along the spirit of adventure and exploration that has guided us so far. We have learned so many things by learning science. In grade 6, we discovered how science begins with wonder. With simple why the stars are shining, why water is taking form of ice, and how questions about the world around us. In grade 7, we learned that science is always evolving. Evolving means that each answer opens new question. You get an answer and then also you get a question also. And how our ideas can slowly change as we explore deeper. Okay, when we investigate on an idea, so we go deep and deeper, and our thoughts and our ideas slowly change. Now in grade 8, we take the next step. And what will be that next step? Entering the investigative world of science, where we will do a lot of investigation, where wonder and evolution come together to form the heart of how science works. Okay? Now in this grade, you will investigate the world of science with the help of wonder and evolution. We don't want you to just learn new facts. Okay? Facts will be same. We want you to learn how to find new facts. Okay? You will try to find new facts yourself, children. Investigation in science means more than just looking at something and asking only simple questions. Okay? Now you can ask more focused questions and design ways to perhaps do simple experiments to answer those questions. You will ask questions and you will also design ways to find out the answers of these questions with the help of some experiments, and then use your observations to improve your understanding. So children, step by step we will learn how to use questions as starting points. Okay, so you will learn here that how you can use your own question as a starting point to try to observe carefully, experiment thoughtfully, and explain clearly what we see. Okay, suppose children, a question comes in your mind and you want the answer of that question related to science. So what you are going to do now, you will investigate with the help of a question, and then you will observe your question. You will start to do experiments very thoughtfully, and then you will explain clearly what you are going to get. In doing so, each of you won't just be learners but also investigators. Okay, because you are finding the answer yourself by investigating. Young scientists exploring real world puzzles. These may range from everyday life, like why does dough rise, to the bigger mysteries of earth and beyond, like is the world getting warmer. As you turn each page of this book. We hope you notice the interesting design of our page numbers once again. On the left hand pages, at the bottom you will find the image of a root. Okay, what you are going to find? Image of a root, symbolizing the deep solid foundation of knowledge that keeps us connected to our environment, traditions and our cultural and natural heritage. On the right hand pages, children, in the top corner, you will find a kite soaring in the sky. Okay, are you looking in your book? Reminding us that curiosity must take flight if we are to explore the unknown. Together, these two symbols, the root and the kite, invite you to stay grounded in real observation. Okay, be thoughtful, be grounded, while allowing your ideas to soar towards new horizons. Remember children, investigation in science works best only when we balance. We have to balance the solid ground of careful observation with the freedom of creative thinking. So children, we should have the freedom of thinking, but we have to stay grounded with our thoughtful observations. You will also notice some patterns. Okay, you are going to notice some patterns also in the lines at the bottom of the page. There are some hidden scientific thoughts in these as well. But don't worry, they are mainly to make the page a little less boring. Okay, let us now take a brief look at the various stops on our journey this year and see where our curiosity, supported by strong roots and lifted by soaring ideas, might take us. Okay, so let's take a look. This year, our investigative adventure will take us on a journey from the tiny microbes we can't see to planet-wide challenges we can't ignore. Okay, so we are going to investigate about tiny microbes also and planet-wide challenges also. We will start by examining something as small as a single drop of water and uncover a hidden world of tiny organisms, unseen but deeply linked to us. Children, these organisms, we cannot see them with our bare eyes, but our life is deeply linked with them. Some of these are invisible helpers that help us digest our food or produce medicines. Okay, we have some good bacteria in our body that help us to digest our food, while others can be harmful, causing infections also. But what does our body need to stay healthy? How do we fight these infections? We will find out how nutritious food, exercise, medicines and vaccines help us stay healthy and fight infections. So these questions continuously come in our mind, that why does our body need to stay healthy, how exercise, healthy food can help us to stay healthy, how we can prevent ourselves from infections, right? But that's just the beginning. In today's world, science does play a major role in improving our lives. For example, we use electric current, right, in many ways to help make our lives easier, right children? We depend on the heating effect of electric current to keep us warm, while the magnetic effect helps motors run and machines functions. And what all these things do, children? These make our lives easier. These phenomena depend on fundamental forces. Now what is a force? So after watching electricity do work, how electricity works, we move on to study these forces themselves, starting with those that make objects speed up, slow down or change direction. How it happens, how the object speeds up, slows down and changes its direction due to force. Understanding forces helps explain why a ball thrown up in the air falls back to the ground, how it happens, or why a car stops when the brakes are applied. So, is it true? Yeah, this is true. With that, when we apply the brake, the car suddenly stops. And when we throw a ball up, it falls back to the ground. This also leads us to the idea of pressure, how the force is distributed over an object. The same concepts of force and pressure also decides how air moves. A small difference in pressure can result in a gentle breeze, while a stronger pressure difference can lead to strong winds and sometimes even cyclones. So, these forces are connected, they all are connected to powerful weather events like storms and cyclones that affect our daily lives, agriculture and even our safety. So children, a gentle breeze, storms, cyclones, this is all because of forces which are connected to powerful weather events, and it also affects agriculture, our lives and our safety also. To truly understand how air can exert pressure or why water balls at the certain temperature, we need to zoom into these materials and see what kind of particles they are made up of and how they move around. Okay? So, to look all these things, what we need to do? We have to zoom into these materials. Everything around us is made up of tiny particles. We know that. In materials that are solid, these particles cannot move, okay, much, while in gases they can move around freely. Classifying things around us is an important feature of science, okay. So, to understand science in a better way, we have to classify things. We can also classify materials around us into elements, okay. Elements are known pure substances, compounds, two or more elements bonded together, and mixtures, combinations that can be separated physically. Once we know how particles combines or mix, we can then understand solution. So, first of all, we will understand about the particles, how they combine and how they mix. Then we can understand about solution also. For example, how sugar dissolves in tea to make it sweet. Once we know how particles combine or mix, we can then understand solutions, right? So, from the world of particles and mixtures, we then move into the world of light. We will study how light rays reflect off flat and curved mirrors, how it gives effect on flat mirror, how it effect on curved mirror, and bends when passing through lenses and helps us understand the working of many objects around us. The bending of light explains what happens when we see an image in a shiny metal spoon. Okay, so it is explained by the bending of light, or how corrective glasses help many of us see clearly. It's not just a polished mirror that reflects light. Rough surfaces reflect light as well, and so does the moon also, depending on the relative positions of the earth. Okay, so it depends on the position of earth. Moon and sun, a slightly different part of the moon is illuminated each night, giving rise to the beautiful phases of the moon that we see in the sky. Look at the picture of moon here, children. Watching the periodic cycles of the moon's phases allows human to come up with the first calendars. By combining careful observation of sunrises, sunsets and lunar cycles, various calendars came into being. Isn't it fascinating that the calendars which determine our routines on earth are linked to the motion of objects far beyond our planet? And we are running our lives according to these calendars. But it's not just calendars on the movements of the sun and moon that are linked. Right here on earth, there are marvelous and complex patterns of relationship between living organisms and their environments. Every living being, from tiniest insect to the largest whale, from blades of grasses to tall trees, depends on and responds to the air, water, sunlight and other organisms around them, forming the ecosystems that support life on our planet. So children, with particles, with motions, forces, pressures and the changing position of sun and moon, you will learn about the ecosystem also, where tiniest insects to the largest whale exist, where blades of grasses to tall trees are there. Okay, we go ahead. In the final chapter of this book, we can put it all together and try to understand what makes Earth just right for life and to recognize the urgent challenges that our planet now faces. Most importantly, the Earth lies at the perfect distance from the sun, where water remains liquid and it has an atmosphere that provides the oxygen we breathe while shielding us from harmful ultraviolet rays. But human activities on the planet can cause small changes in the temperature of the Earth, disrupting climate patterns with dangerous consequences. With all these things, children, you will learn in this book, and then you will find out that how you can save your environment, how you can come out from these dangerous consequences. At the heart of both the problem and any possible solution is us. We are the ones influencing Earth's climate, right? We are polluting air, we are polluting water, we are polluting our environment. But we are also the ones who can and must use science to understand these changes and guide our actions. The same scientific principles that we have guided our journey through the middle stages, observing, measuring, experimenting, will be key in helping us protect the delicate balance on which life depends. The challenges ahead won't always be easy. We hope some of you will try to solve these difficult problems with curiosity as your guide. Now, to help us think like a scientist, let us go back to a question we asked on the first page. Why is one side of a puri thinner than the other? Why? Firstly, remember that science is everywhere. Wherever you see children, you will find science. You don't need a fancy laboratory to do simple experiments. Even your kitchen at home is a wonderful place to observe and ask questions. All you need is to start with curiosity, careful observation and asking what happens if. Okay? Have you noticed how a puri or a bhatura puffs up, okay, when placed in hot oil? Or how a full car swells when put directly on the flame. You must have seen these things. Why does it puff up like a balloon? And why is one side thinner than the other? How it happens and why it happens? These are questions a scientist might ask, and you can too. Let's see how we can investigate this simple everyday phenomena like a scientist world. First, we will try to ask a scientific question. What are the different things that may change the way a puri puffs up when fried? Okay, to answer this, we may want to do some simple experiments. If we want answer of this question, for that we try and find out two main things. What all can we change or control when we do the experiment, and what all can we observe to see if these changes made any difference. In this case, we can perhaps think of the changing the thickness and the size of the rolled dough. Okay, we could also try to use different types of flour. We can take atta also, we can take maida also. While frying the puri, we can also change the temperature of the hot oil. Okay, we can raise the temperature or try and drop the rolled dough into the oil in different ways. Drop it vertically, slide it at an angle, slide it slowly, slide it fastly. Notice that these are things that we can control, right? However, to make senses of these changes, we also need to think of what we can observe or measure. Some of these may have just yes or no answers. In some cases, there might be a number we can measure, or we can measure the time it takes to puffs up, like seconds. We can check whether a very thick layer of dough still gives a thin side of the puri. Further, while doing such experiments, it is better to change only one thing at a time while keeping the other conditions same, so that we can see the difference clearly. For example, if we wanted to see the effect of boiling hot and not very hot oil, we would use circles of dough of the same thickness, okay, and drop them in the same way. We will put it in the very hot oil, we will put it in the slightly hot oil, we will put it in the hot oil. It is also a good idea to keep notes of everything that you see and sense when doing an experiment, okay. You should take notes so that you can write down all your observation in that notebook. Did the oil splatter, smell or smoke? And after doing one round of experiments, you may think of more questions. Do puris puffs better when made fresh or from stored dough? What happens if I prick a hole in the puri before frying? This is exactly how all scientific experiments from simple to the most complicated are done. Okay? First we start with a simple question, and after getting that answer, we make more and more questions about that answer also. This is the idea of systematic investigation, and just so you know, even this simple everyday observation of a puri puffing is not really completely understood by scientists today. So, whether it is the puffing of a puri or the shrinking bright part of the moon after Purnima, let your careful observations guide you along your explorations into the investigate world of science. So children, stay tuned, have questions, feel free to ask anytime. Looking forward to a great year ahead.